Hi and welcome to Radicals Day 1. Today we are talking about radicals. You have learned them before and we're going to be using what you learned and then learn some new things this year as well. The symbol that we have here is the radical. The number underneath it is the radicand, and sometimes we have a number up here in this corner and we call that the index, and that's for taking roots other than the square roots. So what we've got here is a bunch of different examples. The square root of x squared, you know, is x. The square root of x to the cube, x cubed is like saying the square root of x squared times x, and that's equal to x radical x. The square root of x to the fourth is x squared, and the square root of x to the fifth is like saying the square root of x to the fourth times x, which is equal to x squared radical x. The square root of x to the sixth is x cubed. The square root of x to the seventh is like taking the square root of x to the sixth times x. So it's x cubed radical x. And finally, the square root of x to the eighth is x to the fourth. Right, now we're going to start to get into some numbers. Negative radical 4 is like saying negative 1 times the square root of 4. So that would simply be negative 1 times 2, which is negative 2. I have the square root of, or plus or minus the square root of 121, so that would be equal to plus or minus the square root of 121 is 11. The square root, or negative square root of 25 over 81, I just take the square root of the numerator, square root of the denominator, and because it's negative out in front, it becomes negative 5 over 9. And for the next one, I have a negative 2 squared under the radical, and the square root and the radical simply cancel each other out. Well, actually what we should say is if I take negative 2 and I square it, I get 4, and the square root of 4 is then 2. And if you look at all of our answers from here to here, you see that they're all whole numbers. I don't have a radical left in my answer. So these are what we call rational. Let's see here. If I get the page going, here we go. The square root of, or 2 times the square root of 28 is going to be 2 times the square root. To break down 28, we need to find the largest perfect square that divides into 28 evenly, and that would be 4 times 7. And if you remember from either 8th or 9th grade, when you simplify it, you take the square root of the perfect square. You can take that guy, that's the perfect square, the perfect little goody-goody. You can take him out of jail. The 7 is not a perfect square, so he's the radical. He's bad. He has to stay in the jail. So I would get 2, because it's already on the outside, times the square root of 4 is also 2, and the radical 7 stays as it is, and 2 times 2 is 4 radical 7. For the next one, I have 3/4 times radical 40. 3/4 stays out in front, and I break down 40, 4 times 10. And after I do that, I keep my 3/4 out in front, times 2 times radical 10. The 4 cancels with the 2, so I'm left with 3/2 radical 10. And for the next one, I have -6 out in front, and 75 breaks down to 25 times 3. So this becomes -6 times 5 radical 3. So I will have -30 radical 3. Those couple of problems that we have right here, where we had a radical in our final answer, we call irrational. When we have variables in there, we don't call it rational or irrational. So if I need to simplify the square root of 600x squared, I'm going to break down 600 to 100. 100 times 6, and x squared is a perfect square, so we just leave it. And the square root of 100 is 10. The square root of x squared is x, and 6 can't be simplified, so it stays 10x times radical 6. And for my last one here, I have radical 48 times m to the 7th. That would be equal to, the largest perfect square that goes into 48 is 16 times 3, and then m squared times m. So this would be 4. Square root of m to the 6th is m cubed, and then radical 3m. Okay, all the radicals there should have been review. And now we're going to talk about perfect cubes. You may or may not have talked about them before, but one cubed is equal to 1. 2 cubed is equal to 8. 3 cubed is equal to 27. 4 cubed is equal to 64. 5 cubed is equal to 125. And then 6 cubed is equal to 216. Those are just some of the numbers you should be familiar with. It really doesn't go any higher than that. And let's try here. So if I have the cube root of x cubed, it's like saying the square root of x squared. So they just simply cancel each other out, and I'm left with x. The cube root of x to the 4th, I need to break down to a perfect cube, so it'd be the cubed root of x cubed times x, and that would be equal to x cube root x. Now I need to do the same thing with the fifth, break it down into something that we can identify here. So this is the cube root of x cubed times x to the second, which is equal to, the reason I'm breaking it down the way I am is my exponents, when I multiply, I add the exponents, and 3 plus 2 is 5. So I'd end up with x cube root x squared, because I could take the cube root of x. Cube root of x to the sixth is simply x squared. The cube root of x to the seventh is broken down to the cube root of x to the sixth times x, and the cube root of x to the sixth was x squared, and then it is cube root x. And then the cube root of x to the eighth will break down to the cube root of x to the sixth times x squared. So in this case, that would leave me with x squared cube root x squared. Cube root of x to the ninth is x cubed. Now notice the ones that came out without a radical. This one here, and this one here. You notice that 3 goes into 3 one time, 3 goes into 6 two times, 3 goes into 9 three times. And that's where I'm getting my answers from. I'm dividing, when I'm taking root, I'm dividing my powers. And if I go back to the fourth root of x, if I think about it this way, 3 goes into 4 one time, and I'm left with 1. Looking at x to the fifth, 3 goes into 5 one time, and I'm left with 2. For x to the sixth, 3 goes into 6 two times, I have nothing left over. For x to the seventh, 3 goes into 7 two times, notice my exponent is 2, and I have 1 left over. For x to the eighth, 3 goes into 8 two times, again look at my exponent, and I'm left with 2. 3 goes into 9 three times. Okay, now I need to simplify using numbers. And something we need to know is that a negative under a radical is okay if it's an odd root. And the cube root is an odd root. So I'd have to ask myself, what can I multiply by itself 3 times to give me negative 8? So negative 2 times negative 2 is positive 4 times another negative 2 is negative 8. So negative 2 is my answer. The cube root of 27 is 3. Cube root of negative 64 would be a negative 4. And the cube root of 125 is 5. All those values came from what I had written down up on the top of the paper. 2 to the second power is 8, 3 to the third power is 27, 4 to the third power is 24, 5 to the third power is 125. All I've done is just gone backwards. Okay. Now, let's look at what we have here. I have 5 halves, cube root of 40. 40 is not one of those numbers that's listed across the top of my paper. Therefore, it's not a perfect cube. So I need to break down 40 just like I broke it down before with a square root, except this time using perfect cubes. So it's going to be 5 halves, cube root. The perfect cube that goes into 40 is 8 times 5. So that will be equal to 5 halves out in front. The cube root of 8 is 2. And then I'm left with the cube root of 5. Here, my 2's cancel each other out. So my final answer is just going to be 5 cube root 3. Or sorry, 5 cube root 5, not 3. Because that was a 5 there. It's hard to read. If I said 3, I meant 5. Sorry. For the cube root of 1/27, 1 is a perfect cube and 27 is a perfect cube, so it is simply 1/3. I have the cube root of 40w to the 5th. Well, we already broke 40 down up here to 8 and 5. So I have the cube root. It's not letting me write my cube there, but that's cube root of 8 times 5, and this would be w to the 3rd times w squared, which is equal to cube root of 8 is 2, cube root of w cubed is w, and I can't take anything else out, so I'm left with the 5 and the w squared. For this one here, I have that -2 out in front. And my cube root. 54, the perfect cube that divides into 54 would be 27 times 2. And y cubed is already a perfect cube, so I can just leave that. And when I simplify, I'll have -2 times the cube root of 27 is 3. Y cubed becomes y, and I'm left with the cube root of 2. So if I clean that up, I'm left with -6 y cube root 2. And then the very last one here with -48 would break down to -8 times 6, perfect cube. The cube root of -8 is -2. Cannot take the cube root of 6, so it is cube root 6. All right, next page. We're almost done. Every so often you will see a fourth power. Not very often, but the fourth power is just like a third power. What times itself 4 times will give me that answer. And the cube, or the fourth root of 16 is 2, because 2 times 2 times 2 is 16. And the cube, or the fourth root of 81 would be 3 times 3 times 3 times 3. And the last one there is simply just a square root, m to the 5th times n to the 8th. So I break that down to m to the 4th m, and then n to the 8th, because it's an even power, I can take the square root of it. Just take half, so it's m squared n to the 4th radical m. There we go. Now, here's some example of real numbers and not real numbers. I cannot take the square root of a negative number. That we need to know to solve these little equations. All right, to solve m squared equals 144, I could simply take the square root of both sides. And when I do that, the square root of m squared is m, and the square root of 144 is plus or minus 12. If you choose to use this method, my guess is you will forget your plus or minus. I've been doing this for a long time, and I know that that's the mistake that people make. You can use that method if you don't forget your plus or minus. And that plus or minus is only needed when you're solving equations. Or the other method for this type of question is to say m squared minus 144 equals 0. Just get it equal to 0. Subtract the 144. And then break it down to m plus 12 times m minus 12 by factoring. So m is equal to negative 12, or m is equal to 12. Hence the plus or minus in the answer. And this is why it is the plus or minus. If I have 5n squared equals 500, I gotta divide both sides by 5. So I have n squared equals 100, and the square root of 100 is n equals plus or minus 10. And the last one, if I want to solve by using the square roots, subtract 2 from both sides, y squared equals negative 2. Take the square root. Well, wait a second, we can't take the square root of a negative number, so there's no solution yet. Stay tuned. Okay? We will be learning how to do that this year, just not right now. I am hoping that you were able to follow along with the notes today. I'm sorry if the writing is a little bit hard to follow. This is the first time using this method with my new equipment, so hopefully it will get better and my handwriting will get neater.